Have everybody's attention, please. Oh, Wilson just got here, so I got to mark him as late rather than absent. Folks, I hear some talking going on in the back. Let's get our focus going here. Thank you so much, Wilson. What do we got here? 8:45. Okay, so I expected this quiz to be pretty tough, and it was somewhat better than I would have thought it would be, because it wasn't multiple choice for the first one, which I thought made the first one much more difficult. Okay, and the second one was maybe a notch up from yesterday's too. So let's go through these questions and get an idea what we're talking about here. So first question here. Let me change the size down just a little bit so that you can see the whole picture at once. All right, so look, we're asked about the domain and range by looking at a graph. What variable is domain? X. What variable is range? Y. So let's do the domain first. First thing is, you always use an X, obvious. Talked about that yesterday. And then we use this less than, and since there's no open circles on the ends, it's or equal to. So that part should be pretty much memorized by now. What you're saying is X is bounded between. Now you got to figure out what numbers is X bounded in between. So I take the left end of the graph, and I go straight up to the x-axis, and I make a mark. That's the lower bound, the lower end. Then I go to the right end of the graph, and I make a line to the x-axis, make a mark, and then I connect the dots in between. So my lower bound is here, my upper bound is here. What is the x value here? It's -5, so I put a -5 there. What is the x value here? It's 8, so I put it there. In other words, I take the graph and I project it, or I squish it onto the x-axis, because x means domain, and I see what part of that axis is covered. It's covered from -5 to 8. Therefore, the domain is -5 to 8. Written this way, very important that you put the x in there and that you have the less than or equal to, less than or equal to. I want to emphasize, if this was an open circle, I would not put the or equal to. Next, I want to do the same thing for the y. The y is the range. We'll do the same thing for the range. So now I'm going to project or squish the graph onto the y-axis. So here I go, boom, I make a mark. That's my lower bound. Here's my upper bound. I set it up with y in the middle this time because y is range. Less than or equal to, because it's not an open circle, it's a closed circle in both cases. Now, what's my lower bound? -3. What's my upper bound? +2. I expected virtually every kid to get that wrong. And lo and behold, I graded Catherine's paper first and it was right, and I was like, oh my God, tell me they're going to get these right. And then most of you missed it. Some got it right. I'd say about 20% of you. All right? So listen, that's not hard. It's just not something we've talked a lot about. So you have to make it a point to work that this weekend. If you work it this weekend, you will get it right. Any questions? Okay. Now let's go to the next one. Which one is not a function? Now this is kind of tricky because we haven't done too many graphs this year where they're both squared. But this one is not a function. When they're both squared, you're either going to create a circle or an ellipse. Now, let me show you why these other ones are here. Obviously, choice 3 is a line, so no one should have written choice 3. Line is always a function. This is a parabola, choice 2, so no one should have written choice 2. I think it comes down to between 1 and 4. And then it's kind of a little bit of guesswork until now. Do you know how if we graph a parabola and the y is squared, the y gets 2 values? It goes like this, right? Each 2 match up with the y. Well, when the y is squared, you get 2 with the y. When the x is also squared, I should say when the x is squared, you get 2 with the y. When the y is squared, you also get 2 with the x. So what it does is, instead of having the graph go like this, it puts a top on the graph and turns it down. So you make an ellipse out of it. And when you make an ellipse out of it, can you see that you're going to fail the vertical line test?
Yep.
Okay? So that's why choice 1 doesn't work. Easiest thing for you to remember is that if you square both of them, you make an ellipse fails the vertical line test. Also, can you see the horizontal shift going on in this package here? Right? Okay. And last but not least, on the graph, it's choice 4. I think every single kid got choice 4 right. So I don't need to talk much about that. Any questions? Yes?
How would you be able to check number 2? Like, because it has both the X and the Y, and I don't know how to put 2 different variables on the calculator.
Oh, all you got to do is make it say y equals. So I think that this says x squared over here. Let me make
Also,
this.
you divide it.
You're going to subtract it. You subtract the x squared, and you do the opposite here, and then it becomes y equals negative x squared, whatever, plus or minus 4x plus 4, and that you could put in the calculator.
I meant for number 4. Like if you
Oh, for choice 4?
Yeah.
I would solve for y. I would put 4 divided by x.
Okay.
Okay? Any other questions? All right. So we'll get started in just a minute on today's lesson. But yesterday was Ducky's first day at the house. He arrived home from, I don't know why it's so small. I guess the district shrinks it. In real life, it covers the whole of my big computer here. Yes, that's my son, your sub, Mr. Magic, as they call him at Tremont.
Uncle Magic.
Uncle Magic, okay. We were so busy last night, there was no time to make dinner, and I was in no mood to make tuna fish or ravioli, so we called the pizza shop, and Jimmy delivered at 9:45 last night. And when he dropped it off, he posed for a couple of pictures with Ducky. Now, Ducky is a rather unique dog. As you can tell, he's cute.
It's
He's
National Puppy
cuddly.
Day yesterday.
What's that?
It's National Puppy Day.
I know. How coincidental was that? I don't believe in coincidence, though. All right. So, here's Ducky. We'll get some really good pictures this weekend of Ducky. But Ducky, as I said, he's a little bit of a strange dog. Well, he apparently likes boogers. The tongue went right up into the nose. So,
He's still smiling though.
quite the little guy there. I woke up this morning at about 1:20 in the morning, 1:15, 1:20 to let him out because he was whining in his crate, and it means he has to pee and poop. So I pick him up, I run downstairs, we go outside, and Gibbs went outside with us, God bless. And actually, this was at like 11 o'clock last night, we were going to bed. Gibbs was outside with us, and Ducky's getting along very well with Gibbs. And, you know, Gibbs is a 130-pound dog, you know, and there's Ducky. So the dogs in the neighborhood, when we came outside, started barking, and Gibbs would, like, charge the fence, tell him to shut up, and Ducky was like, yeah, talk to him. So that was pretty funny to see. Here he is resting on Sue's lap a little bit later in the day. The most important test was passed. He gets along with Ziva. Ziva's very tolerant of him. Ziva growled at him once yesterday. Being very likely pregnant. Sunday we have the sonogram test for Ziva. Highly likely that she's pregnant. She's starting to get fatter. She just wants to sleep all day. Her appetite is ravenous. Usually she's the most active dog in the house, constantly doing things. She just wants to be left alone. Unless I'm near, then she wants to be with me. So yesterday, my wife was laying on the couch, or not laying, but sitting on the couch. And Ziva went and laid on the couch next to her and laid her head on my wife's lap. And my wife was just petting Ziva as she was laying there. And the puppy came up and tried to get up onto the couch. All you heard was, learn right away, puppy. If Ziva's getting petted, you just leave Ziva alone. You just don't mess. Not a good idea. So that was the only growl of the day, and they played with each other, and they kissed each other, and they went very, very, very well. And then, at the end of a long day, Ducky, it was night time for Ducky.
Is he supposed to, like, get really big?
No, he'll be really small. He is a mini Aussie Shepherd. So,
Dude, mini huskies are...
what's that?
Did you say he was the size of your computer?
He will absolutely be all over the computer. When he's full grown, he'll be slightly bigger than that computer screen. Okay. Now. All right. Let's not go too nuts on the doggy stuff here. Let's get our focus back in. We got about 10 minutes, 9 minutes left here. And let's get through the lesson. Gregory plans to purchase a video game player. He has $500 in his savings account. Plans to save $20 per week from his allowance until he has enough money to buy it. He needs to figure out how long it will take. What type of function will model this problem? What type of function, guys?
Y equals mx plus b.
Also known as linear. All right, the type of function is linear. What this function would be, the actual function, would be y equals 20x plus 500. Right? You start with 500, that's your beginning amount, your y-intercept, and you go up 20 per week. Okay, next one. One of the highlights in a car show event is a car driving up a ramp and flying over approximately 5 cars, placed end to end. The ramp is 8 feet at its highest point. There's an upward speed of 88 feet per second. What leaves the side of the ramp? Anthony?
Well, the equation would be quadratic.
That's right.
Also, it kind of has like its ups and downs.
That's right. It goes up and down, and that would be a very wide parabola. And early in the year, we did lots of questions like this. And I can remind you of the actual equation. Y equals negative 16t squared, right? Well, we usually use t for time. Negative 16, because that's the force of gravity. Then the speed is 88 feet per second at the upward speed, so plus 88t. And then it jumps from a height, it jumps from ground level, so that's it.
Plus 8.
Okay? All right. Now, let's go to example 3. Margie got $1,000 from her grandmother to start her college fund. She's opening a new savings account and finds out that her bank offers 2% annual interest rate compounded monthly. What would that be? What kind of function? Exponential. Interest population, compounded interest, is always exponential. And the amount in the account, the amount of the account at time t is going to equal 1,000. It's always the initial amount, times 1 point. Now this is where it gets a little bit dicey. Remember we gave you the formula the first day with the n in it? N is the number of times it's compounded, which is 12 times per year. So it's 1 plus 0.02 divided by 12 to the 12t. So the only difference is I put a 12 here and here because I'm dividing by the months and then multiplying or exponentiating back into them. That's because of the factor of how often it's compounded. Okay? They didn't ask you for the equation. I'm giving you the equation on top of it just to go a step deeper. What they want you to know is that this is an exponential function. That's what they want out of this. All right, so now let's go to the next one. City workers recorded the number of squirrels in a park over time. At first count, there were 15 pairs of male and female, 30 squirrels total. After 6 months, the scientists recorded 60 squirrels, and after a year, there were 120. So we go from 30 to 60 to 120. Doing a little sequence there. What kind of function is this? Yes? Mm-hmm. Exponential it is, because you're multiplying to go from term to term, times 2, etc. As far as the sequence goes, we would call it geometric sequence, okay? If I wanted to give it a recursive formula, what is a sub 1? 30. And then a sub n plus 1 equals what?
30.
A sub 1.
No, what are you doing to go from term to term to term?
Multiplying by 2.
So it's 2, a sub n. New term is double previous term. Okay? Write a function that predicts it over x number of years. Now, this is exponential, so f of x is the initial amount. What's the initial amount, everybody? 30 times the common ratio, which is 2, and always to the x minus 1. When we do this is an explicit formula. So when we do the explicit function form with the formula, it's always x minus 1, because I don't need to multiply by 2 to get to the first term. Yes?
What is a sub n or sub n, whatever? What does it mean? Like that?
Listen, all you need, they're really in comparison to each other. N plus one always comes after n. So it's new term, previous term. Or I could have written it this way. And likewise, n comes after n minus one. So that's another way of saying new term, previous term. Okay? All right, let's go to the next one. Rectangular photograph measures 8 by 10 inches, surrounded by a frame, uniform width. Let's just sketch this out. We don't have a lot of time, but we can sketch it. Rectangular photograph, 8 by 10. It's surrounded by a frame of uniform width W. So, W, 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 W. Now, this is about area. So, what is an expression for this width? Go ahead.
2W plus 8 and
Excellent.
2W plus 10.
That's right. Very good. And lastly, how do I write an equation that involves area? Anthony?
Because you're trying to find the area, you have to find because you're finding the area, you have to multiply 2W plus 8 and 2W plus 10 together.
Good. Slow down, bud. 2W plus 10 plus 2W8. Plus 8. Did I do that right?
Yes, yes.
Yes.
Yes. Good. Now, what does it have to equal?
That's the
Why?
It doesn't say. Okay. So whatever they said the area is what I would set it equal to. What kind of function is that? It is quadratic. Very good. Because I'm going to do a 2W times a 2W, which will be 4W squared. Also, area is always squared, and squared means quadratic. Okay? Any questions on this stuff? Heck no? Okay. Very good. So, again, we're just recognizing function types. Sight recognition today was modeling it from the context. Reading the question, knowing if it should be an exponential, a linear, or a quadratic equation.